So, session 1. The first thing when I do this is, if you guys have got a grey lead, and I don't have a grey lead because I've got this little pen here, but if you want to sketch the graph of something like, if we have the graph y equals 36 on 2x squared minus 18, and if you were to sketch this graph here, then sketching that graph, let's take out 2 as a common factor, and I've got x squared minus 9, which is equal to x minus 3, x plus 3. Now if I was to sketch that graph, the graph here, then you would have something like this, wouldn't you? Now you'd have 3 and minus 3, and you'd have some graph that'll look like this. Now you wouldn't do that, but you might want to sketch that in grey lead first to give you an idea that the intercepts, that's where the asymptotes are. So I've got an asymptote at x equals positive 3, and labelling those asymptotes would be worth a mark. So x equals 3 there, and x equals minus 3 here. Now that's the first thing. We've also we've got an asymptote at y equals 0. Okay, so we've got an asymptote at y equals 0. Now if you think about it, let's pick a value which is less than negative 3. For example, if I had just after negative 3, well, that means that this value here would be so small, which means that we would be approaching infinity, or like so. And if I was to have this number here really large, or sorry, really small, negative, then that's going to be very, very small number. So that's sort of how you can get the shape. All right, that's how I get the shape. You can also note that it's symmetrical about a point. We do the same thing on this side here. We've also got an asymptote as well. And the final thing is we have a turning point here, and the y-intercept is when x equals 0, which we solve. What did you guys get? Negative 0, negative 2? Yeah. Okay, so you should have, and because it is symmetrical about the, we should have something like this. So that has an equation or coordinates 0, minus 2. We're labelling with coordinates. Is there anything that we've missed out on? I don't think so. So what do you think the mark would be for? One mark would be, now by the way, that needs to be an asymptote approaching a point. That definitely would not get the mark. All right, you would need to approach that point. Asymptotic sort of behaviour. All right, one mark for the shape. You would also have one mark for both asymptotes being correct. One mark for that turning point. Now, it says here that find the area of the region bound by the thank you. I'm trying to do math as well, you know. We're trying to find this region here between negative 2 to 2. But what do you notice about the graph? It's symmetrical, isn't it? So therefore, the way I've done it is that the area is equal to, well, negative 2 to 2, like so, which is equal to, now I'm going to do, now that area is negative, okay, because it's bound by so it's actually not that area, it's this area in here. And that area is negative, so I'm going to account for that by putting a negative out the front. And I'm actually going to put out a negative 2 because I know that it's symmetrical about that about x equals 0. So I'm going to just make my life a little bit easier and go from 0 to 2. And then I've got 36 outside of 2, x squared minus 9 dx. Don't forget your dx's. Now, what I'm going to then do is take that out. I'm going to take my constant out the front. Those two are going to cancel out. So my area is equal to negative 36, 0 to 2, 1 over x squared minus 9, which is x minus 3, x plus 3 dx. Now we're going to have to do what? Partial fractions. Now, by the way, you don't need to show any evidence of partial fractions, but you do need to do it correctly. So I guess I'm just going to do it the manual way. If you want to do the cover-up method or something like that, that's fine. But what I've got is I've got 1 over x minus 3. I just do it quickly, algebraically, and it doesn't take very long. So I've got this, a over x minus 3 plus b over x plus 3. Now, if I'm multiplying them across, therefore I've got 1 is equal to a outside of x plus 3 plus b outside of x minus 3. And I'm going to let x equal 3. And if I let x equal 3, that would give me 6a is equal to 1, so a would be equal to 1/6. And if I did it the other way, x equals minus 3, I would get b is equal to negative 1/6. Now, I'm going to then plug that in. But what I'm going to do is, let's throw that 1/6 out the front. What are we left with? That's going to leave us with negative, or 36 over 6, which is negative 6 from 0 to 2 of 1 on x minus 3 minus 1 on x plus 3 dx. Now it's worth 4 marks, so we've still got a little way to go. Now anti-deriving, that's fairly straightforward though. We've got minus 6 outside of log to the base e of, I'm going to put this in brackets. I'm going to use my log laws. That's log e to the x minus 3 minus log e to the x plus 3, which means I can just use my log laws straight away. And that's between 0 and 2. Okay, now I'm going to go ahead and evaluate that. So that is minus 6 outside of, well, what we've got first is log e to the 1 over 5. So that's log e to the 1 over 5. And it's the absolute value of that, so we're not fussed about positives and negatives anymore. It was negative 1 over positive 5. So, and by the way, not doing the absolute value sign, would you lose a mark there? Absolutely you would. All right, then we're subtracting log e to the 1, because it would be log e to the 1, which is 0. So therefore, our answer, what's that, matey? Yep. So the answer is minus 6 log e to the 1/5. Now, just quickly, what's 5? Isn't 5 to the power of 1/5 is the same as 5 to the power of negative 1? Yeah? So that's the same as going minus 6 log e, and that's 5 to the power of negative 1. What can I do to the...
Flip it, make it 6 log.
Can't I get that power and bring it to the front? Yeah. So therefore, the answer would be 6 log e to the 5. Now, by the way, would this be acceptable? Yeah. Yes, it would be. So you could just simply stop there if you wanted to, but just recognising that is still, because they're asking for the area, but this here is its positive area. This is a positive result too. Here. Now with this one, can I just get you to... What I'm talking about is addition of ordinates is if I have the graph of 2 over x squared. Let's have just an idea of what the general shape of 2 over x squared is going to look like. Isn't 2 over x squared going to look like something like this? Would you agree? Now, what's the graph of minus x on 2 going to look like? Well, minus x on 2 is going to look something, I don't know, it's going to have a gradient of negative a half. So it's sort of going to look something like this. Now, the whole point of adding these ordinates is what I was sort of saying is, let's think about it. If I was just to add those two graphs together, what's the general shape? When I'm looking at this point here where they intersect, I'd sort of be like double that. And as you can see, if I was adding a very small number, to this x squared graph, then I'm going to be sort of somewhere up here. And as you can see, I'm going to be basically approaching that sort of point. We don't even know, you probably wouldn't realise that there's a turning point there, but I guess the hint is that they've asked you to find the turning points. So basically what's happening is, if you think about it, this hyperbola is going something like that. Now, if you have a look here, what happens if I add the ordinates to this? We've got just underneath, we're looking at around about, very small values of x here, around here. We've got, just under that asymptote there. And we've basically, if you think about it, it would just sort of make sense that we're going to have a shape like that. And that whole process of addition of ordinates could really help you in a multiple choice question, because there's been some real doozies in the past. Now, by the way, that's just to help you get the shape. You might want to do something like that to the side to get an idea of the shape. But we've got 5 marks. Okay? Now, the first thing is that we can say that there's an asymptote at y equals minus x on 2, and the reason that is because x can't equal 0. Now, if x can't equal 0, then y can't equal minus x on 2. So we need to draw an asymptote. Now, if I was to draw something like this, a point here, and I want to go somewhere like this. So they've given you a grid, so you need to be pretty precise, and this is the asymptote y equals minus x over 2. Now, there's also an asymptote, though, at x equals 0, because clearly the denominator can't be 0 for that 2 on x squared. So we've got an asymptote at x equals 0. What some people do is they think there's an asymptote on 2 over x squared. There's not. Okay, because x can't be equal to 0. Which means that it can't equal that. All right, so there's x equals 0 is another asymptote. So we've got an asymptote here. X equals 0. Now what we're going to do is we're going to do some algebra. First of all, we're going to say that dy dx is equal to, I've got minus 4x to the power of minus 3 minus a half. And I'm going to let that equal 0. So therefore, if I've got a half is equal to minus 4x to the power of minus 3, which is equal to minus 4 on x cubed, which basically implies that x cubed is equal to minus 8, which means that x is equal to negative 2. Now, when x equals negative 2, I'm going to say that y is equal to 3 on 2 just by substitution. Now, we've now got, this is the coordinates of the turning point. Okay, so this is the coordinates of the turning point. Now what we're going to do is find Now, by addition of ordinates, would we bother trying to find, if you could see that the shape of the graph is going to look something like this, would you, and you know that there's an asymptote x equals 0, you don't need to find y-intercepts or anything, don't go wasting your time. So get an idea of what the shape's going to look like first. Now, of course, you don't really need to draw anything else other than the fact that, okay, at the point, if I was to have a look at the graph of 2 on x squared, when x equals 1, y would be equaling 2. Okay, so it's going to look something like this, just for the... When x equals minus 1, y would be equal to 2. So that's not the most greatest graph. But you can see there that what we've got is we've got this. But let's try and put that minus 2, 3 on 2. Minus 2, 3 on 2. So we're going to have a graph like this. And label the coordinates. Minus 2, 3 on 2. Now what we're going to do is just find the x-intercept. And to do that we let y equal 0. And so that's going to be 0 is equal to 2 on x squared minus x on 2. X on 2 is equal to 2 on x squared, which is going to mean that x cubed is equal to 4. So, what quite a few of you did, I noticed, is that the solution to that was plus minus. The only way we can get the cube root as positive is if we started with a positive number. So therefore, x is equal to the cube root of 4. And by the way, you just leave it like that. You don't have a CAS calculator, but think about it. The cube root of 8 is 2. The cube root of 1 is 1. So it's going to be somewhere between 1 and 2. Yeah? So basically, if you guys go ahead and you trace this down, and it's definitely going to be careful though. If you just did something like that, and then you just labelled that coordinate as the cube root of 3, as long as you were somewhere between 1 and 2, you'd get your mark. Okay, the cube root of 4 and 0. Resume now. So, on your formula sheet, this is what you have. Now, I briefly explained before, not that you would have to do this, because you should have this committed to memory, the formula sheet, but the graph of sine of x looks like that. Now, if the graph of sine of x has a range between -1 to 1 inclusive, then the domain of the inverse is going to be the range of the original. So that's where that comes from. But remember, in order for an inverse to exist, then we need a 1-to-1 function. So this sine of x graph, we're basically cutting it off between -pi on 2 and pi on 2, because then it is a 1-to-1 function. In other words, it will pass the horizontal line test. That's the only way it can exist for this function. But anyway, moving aside, this is the easiest way to do it. From the formula sheet, if we want to work out the domain, what we do is we say that the domain, -1 to 1, and that value which is inside the brackets, a half x plus 1, is in between that. That is your new implied domain, we need to solve for x basically. So in other words, if I subtract 1 from both sides, I've got -2 to a half x and 0, and then I multiply both sides by 2, I've got my answer. -4 to 0. There you go, I've got my domain. Now, as far as the range is concerned, I think the easiest way to work out the range is more just the transformations. think about it. What is this 2 on pi doing to this graph? That 2 on pi is basically multiplying. If you think about it, we could just work. Remember, we just need to find the answer. So if I was to get minus pi on 2, which is the smallest thing, and I was to multiply that by 2 on pi, that's going to be like the first transformation that takes place. Pi on 2 multiplied by 2 on pi. So I'm just looking at the transformations. Now that's going to be equal to negative pi to pi. But then what are we doing? We're subtracting 3, aren't we? Oh, actually not negative pi to pi, it's negative 1. It's negative 1. And then we're subtracting 3. So it's negative 1 subtract 3. And the other one is 1 subtract 3, which is... So therefore the range of f is equal to negative 4 to negative 2 inclusive. So the range is usually a bit harder because you've got to apply the 2 transformations. This one over here deals with that constant out the front, and then once we multiply that through by that constant out the front, we then need to subtract 3 from every value of y. So that is your answer there. So that's 1 mark, and this is the other mark. Okay? Domain and range. Now, it then says, now, I bet you a lot of people would have made mistakes here. I'm gonna insist that in exam 1, you should use the chain rule and use it properly. Don't do too many shortcuts, because ultimately, if you get it wrong, you're going to drop some easy marks. So what I'm going to do is I'm going to show the long way. And by the way, I still do this because sometimes I forget these sort of things, like applying the chain rule properly. Okay? So let u equal a half x plus 1. And you know what? Until you start getting this right every time, then I suggest that you probably stick to this method too. Du dx is equal to a half. I'm going to let y equal 2 on pi inverse sine of u minus 3. And I'm going to let dy du is equal to... And when I have it like this, I can use the formula sheet. I don't have to do any manipulation. Dy du is equal to, well, we've got the 2 on pi out the front, and then that's times 1 over, and this is straight from the formula sheet. I can use the formula sheet because I've used this chain rule. Now, dy dx is equal to dy du times du dx, which is equal to a half times 2 over pi times 1 over the square root. Now I'm going to substitute u in now. Now I'm going to do that as 1 minus, and u is a half x plus 1. So a half x plus 1 all squared. Now those 2's are going to cancel out. Those 2's are going to cancel out, and what I'm left with is equal to 1 over pi, and I'm going to just do this in my head. A half all x all squared is x squared on 4, and then that 1's going to be subtracted away, and then we're going to be adding x but then subtracting it away. So therefore we've got x squared on or negative x squared on 4, and then we've got to have minus x. That's what that's going to work out to be. Now, I'm going to then take out, we could take out a highest common factor, or we could take out, let's just take out minus x on 4 as a highest common factor. So what we've got is minus x over 4. What have we got inside there? We've got x plus 4, would it? X plus 4? Yeah. Okay, now I've got that. The square root of 4 is 2. And there, what I've actually got is this. I've got 1 over pi times, well, that's a half. Negative x plus 4. And then that 2 is going to go to the top. Okay, 1 divided by a half is 2. So that 2, so it's going to be 2 over pi minus x plus 4. And that's your answer. And if you wanted to, you could say that A is equal to 2, B is equal to negative 1, C is equal to 4. Technically it doesn't, but at least then you've confirmed that you've got it in the right format.
Can you just leave it there? So B equals negative 1 over 4 and H is equals to 1.
What has it done?
Oh, it's using integers. Okay.
Integers. All right. So I'm going to stop there.